Hello students, let us learn about an introduction about analog transmission. This is the chapter outline. We have a digital to analog conversion and then we have analog to analog conversion. Digital to analog conversion is the process of changing one of the characteristics of an analog signal based on the information in digital data. Figure shows the relationship between the digital information, the digital to analog modulation process, and the resultant analog signal. In this case, digital to analog implies converting digital data to analog signals. So here, let us see this diagram. We have digital to analog conversion. We have a digital data here on the left side, and we have a modulator. The modulator will convert the digital signal into analog signal, as we can see, and then we will receive a digital data at the end of the receiver. Okay, so the most important part is played by this modulator and demodulator. Modulator changes the digital data to analog signal, as you can see, and then the modulator changes the analog signal to digital data. Why do we need to change digital data to analog signal? Is that in a link we cannot send digital data as it is, because we need to have a sine wave or a cosine wave of analog signal to send in this link, because this link may be cable driven by electric power, so we cannot simply send a digital data on the link. That is why we need a modulator and demodulator, as well as a digital to analog conversion. Now let us see the types of digital data to analog signal conversion. We have amplitude shift keying, frequency shift keying, phase shift keying, and the combination of amplitude shift keying and phase shift keying, we have QAM, quadrature amplitude modulation. Okay. Before we discuss specific methods of digital to analog modulation, two basic issues must be reviewed. Number one is bit N, number two is baud rate, as well as a carrier signal. This time we will concentrate on bit rate and baud rate. This is your bit rate, and then we have a baud rate. Bit rate is the number of bits per second. Baud rate is the number of signal elements per second. In the analog transmission of digital data, the baud rate is less than or equal to the bit rate. So what do you mean by bit rate? Bit ganti chuan 1 2 3 4 4 bit hi second khada kalta se kan lo transmit man ta a 4 bit hi ani chuan kan bit rate chu 4 bits per second ti na lo ni mai ta a ani le 4 bit hi an signal pakhat siam thung se 4 bit hi one signal ni ve thung ta se kan baud rate chu ngai ni ta ang kan ti chuan 1 baud rate ti nan lo ve thung don ta ni second khata bitli khakal ma se bitli khan signal pakhat chaw siam si chuan, then we have a baud rate. Okay, so chuan ani chuan baud rate hi bit rate ai na tam thei lo shim shim ani. Bit rate le baud rate ai an theina chu 1 bit rate hi 1 bit hi 1 baud ani in ai nang theya. Okay, ani lo chuan 4 bit hi 1 baud ani theya, 8 bit 1 baud ani theya, khating zel khan bit tam tak khan 1 baud chaw siam theini signal pakhat chaw siam theini kan hret chen tur chu baud rate chu second khata signal elements engzak nge kan thon thei tina ani. Formula hi lo en lo gela s equal to cn by r antia, where r is equals to bit per second or equals to log 2l, and l is the number of levels signal elements, n is the bit per second. Okay, n is your bits per second, and s is your signals per second, which is your baud rate. This is your bit rate, this is your baud rate, and c is equals to 1 for broadband, that is digital to analog in 1, and c is equal to half for baseband, that is LAN, where we have a digital to digital conversion. Okay, we will take c equals to 1 because we will be talking about to digital to analog conversion. That means s will be equals to n by r. All right, now let us give an example. An analog signal carries 4 bits per signal. If the signal rate is 1000 baud, find the bit rate. So what we need to do is, we have bits per signal are equals to 4. Alright, this is your 4 bits per signal. Signal rate is 1000 baud. Signal rate is signal baud 1000 baud. Find the bit rate. We need to find the bit rate n. Now we already have a formula. S is equal to C n by R, where C is equals to 1, which is equals to n by R. Alright, by using cross multiplication, therefore n is equals to S into R. That is, n is equals to, substituting the value of S, 1000 into R is 4, which is equals to 4000 bits per second. We can answer low nitani. Ani chon ti zong hin lo clear le thung tai la. An analog signal carries 4 bits per signal atia. Om je chu signal pakhatin one signal equals to 4 bits ti nani. Pero if the signal rate is 1000 baud, om je signal rate kan ti chuan second khata khan signal en zan nge kalman kan ti chuan second khata signal sang khat akal manani per second ti na lo ni ta a. Ani chon bit rate chu nge kan ti chuan signal pakhat hian bit li zel anei chuan signal sang khat chuan bit sang li anei don ti na ni mai ta ni. Heti formula chu lo pan pakla hisapon a hre thiam dei na na ti khan lo hre shim shimila thange. Next an analog signal has a bit rate of 8000 bps and it's n equals to 8000 bits per second, and a baud rate of 1000 baud. Baud rate s equals to 1000 baud. How many data elements are carried by each element? R equals to signal per second. How many signal elements level do we need? Elements level kan ti chuan L kan hre tangai bok tani. These are the two questions that we have to solve. Alright, and then we already have the formula. S is equals to C n by R, but C equals to 1 in digital to analog conversion. So we have S is equal to n by R, or R equals to n by S. Therefore, R equals to n to 8000, and here we have 8000 divided by 1000, which is equals to 8 bits per baud. Alright, or 8 bits per signal. And then we have to find the value of L. We also know that we have this formula. R equals to log 2 of L. And it's on log hilelam pangkandap hevetong suan. This will result to L equals to 2 to the power R. Okay, this is the formula. That means R will be equals to 2 to the power 8, which is equals to 256. So the level of signal elements that we need will be 256. Okay. Kan bit rate nei kha 8000 bits per second ania. Kan baud rate nei kha 1000 baud ania. Om je chu second khata bits sang ria da kala. Bits sang ria da khan signal sang khata omani chuan bit ria thian signal pakhata siam ti nani. Mun takin han en tawla. Bit sang ria ti second khata kal mana chung zinga chuanin signal sang khata om man chuan 1 baud hi chuan om je chu 1 baud hi 8 bits ti na lo ni tani. Bit rate hian signal pakhat 1 baud a siam ti nani. Okay, hi ti hitrang hin a hre thei ngal ta ani chuan R hi chu kan hre ngal ti nani 8 bits per baud. Baud khata hian 8 bits om ti na. So how many signal elements do we need nti ve thung chuan he kan formula r pakhat kha ni a r formula dang ani a r equals to log 2 l ani a l hi kan signal elements level so inani chuan level engzai kan momo kan ti chuan l equals to the power r ania l equals to r to 8 ania to the power 8 ania which is equals to 256. We will need 256 levels. Okay, for this one ka bit le Baud chung chang ani e lo me